Rohini College of Engineering and Technology from Department of Civil Engineering. So the subject is in our civil engineering subject. So 7th semester for final year students. Then our subject title is C8703 Structural Design and Drawing. So I'm Michael Devadure, Assistant Professor. So today we are seeing about the topic is design a RC water tank. RC means reinforced concrete water tank. So unit 3 liquid storage structures. So see our syllabus. So RCC water tank, then on ground portion, then elevated circular, then underground rectangular tanks, then hemispherical bottom steel water tank, then all the design and drawings. So in this unit our course outcome is design and draw reinforced concrete and steel water tanks. So example, design an rectangular RC water tank resting on a ground with a top open for a capacity of 80,000 liters. So the inside dimension of the tank may be taken as 6 meter into 4 meter. Design the side walls of the tank using M20 grade concrete and Fe 250 grade 1 mild steel. So draw the following views, the cross-sectional elevations of the tank showing reinforcement details in the tank walls. Plan of the tank showing reinforcement details. So in this question they will ask to design a rectangular RC water tank for resting on a ground. So they will given in our dimensions of the tank also given 6 meter into 4 meter. Then inside walls, then that capacity will be given. Then M20 grade and Fe250. Then step 1 given data. So capacity of the tank is equal to 80,000 liters. Then size of the tank is equal to 6 meter into 4 meter. Then freeboard is equal to 150 mm. Then FCK is equal to 20 Newton per mm square. Then FO is equal to 250 Newton per mm square. So all the values are given in our question. So step number 2, permissible stress. So sigma CC is equal to 5 Newton per mm square. Then sigma CBC is equal to 7 Newton per mm square. So these values are taken from our code book IS 456 2000. So modular ratio, page number 80. Okay, IS 456 2000, page number 80. That modular ratio will be 280 by 3 into sigma CBC. So sigma CBC and sigma CC values are from taken from code book, page number 81. So sigma ST 115 Newton by mm square for near water phase and sigma ST 125 Newton by mm square for away water phase. So this sigma ST for all the steps based on the phase of the water. Because a near water phase you will take as a 115 or away water phase you take as a 125 mm. Then Q is equal to 1.41 and J is equal to 0.84. We will take as a assumed value. So step number 3, dimensions of tank. So finding the dimension, if you know the one condition, 1 meter cube for 1000 liters, this is our condition. So free body is equal to 150 mm. So convert to meter 0.15 meter. So height of the water is equal to capacity by size of the tank. So height of the water is equal to 3.33 is will be given. So we are rounded as 3.35 meter. So height of side wall H is equal to height of water plus freeboard. Freeboard is 0.15. So 3.35 is the height of water plus freeboard is 0.15. So add the total, you will got the height of the side wall. So total side wall is 3.5 meter. Then L by B ratio is the less than 2. Then the intensity of pressure. So P is equal to W into H minus H. So H is the capital H height of the, then W is the assumed. So step number 4, moment in side walls. So we need to find out the moments in our side walls. So we have the 4 sides. So L is equal to 6 meter and B is equal to 4 meter. So PL by square divided by 12. So for 6 meters are 2 sides and 4 meters are 2 sides. So we need to find out the separate bending moments. So formula is the PL square by 12 for 6 meter side, for PL square by 12 for again on 6 meter side. Then again on PB square based on L, based on length for 2 moments, based on breadth for 2 moments. So PL by square by 12. So yeah, P is equal to 25. 25 is our load, pressure and density. Previous step we can find that. Then L is the 6 meter. And PB square by 12. So P is the 25 meter. And B is the 4 meter. So PB square by 12. So same formulas. So apply the values. You got the moment values. Then moment at support. So 34 plus 75 minus 7. So for our example, so one side of support you need to find out the we have the four sides of walls. Okay. First of all, one thing on your mind, we have the four sides of walls are there, but we need to find out the support. So we have the four supports are so there. So any one support you can say the one corners of side support. You can minus the remaining two sides wall moments. Okay, you will be taken a side moments. So minus the B and C moment. So for example, so 34 is the one side corner of the moment. So 75 minus 50 is the B and C sides of moments. Okay, so the moment at support is equal to 59 kilonewton meter. Then moment at center for long walls. Long walls means based on the size. Moment at center is equal to 112 moment minus support moment. So center moment. So neglecting the support moment, supporting acting moments. The moment at center short walls. So moment short walls minus supporting moment. So minus 9 kilonewton meter. Then this is our bending moment diagram. See that. So 59 is the moment at support. So support A and imagination the two supports are A and B. Support is the 59 59. Then plus 53 is the center wall, long walls for center wall. So our short wall is the outside, we have the marked as the short wall minus 9. Then step number 5, design of long wall and short walls. So we know the formula maximum design bending moment is equal to 59 km. So D square is equal to maximum moment by Q into B. So maximum moment is 59 10 power 6. So 1.41 into 1000. B is equal to, you can assume this is 1000 mm. So D is equal to 204 mm. So adopt effective depth. D is equal to 215 mm. So overall depth capital D is equal to 215 plus 25 is equal to 240 mm. So direct tension in long wall. So T is equal to 0.5 into 25 into 4. 25 is the unit of concrete, 4 is the size of the walls, the 0.5 is the formula. So 50 kilonewton. Then direct tension in short wall. So same formula, size only will be changed. 6 meter and 4 meter. So this is 75 kilonewton. Then AST for long wall corners. So x is equal to 215 minus 125 is equal to 90 mm. So our AST formula is m minus tx divided by sigma st into j into d plus t divided by sigma st. We know all the values. So apply the values, you got it the answers. Then see the diagram, the x will be finding out from this diagram. Okay, so our x is the 2115, then minus 125, we got the x values. Then spacing, we AST we find it, then again we finding out the spacing for all the problems. So provide 20 mm dia bars, we need to provide 20 mm dia bars. Then spacing, we know the formula 1000 into by d square by 4 divided by AST. So D is equal to 20 mm we can assume. So apply that. Then AST is equal to 3480. That's also apply. The spacing is 90.27 mm. So provide 20 mm dia bars at 90 mm center to center distance. Then reinforcement in center of span for long walls. For long walls reinforcement, so formula moment at center minus Tx divided by sigma St into J into D. So we know all the values, so just apply the values, you got the answer. Our answer is 2500 mm square. So half the bars from inner face of the support. We need to find out the, in our inner face of the wall, find out the half of the reinforcement. So in one wall, one outer face are there, one inner face are, two reinforcement are placing in one between wall. So we need to find out the inner faces because a reinforcement divided by 2. So AH is equal to 3928 divided by 2 is equal to 1964 mm square. So for remaining area, 2500 minus 1964 is equal to 536 mm square. So provide 6 mm dia bars at 150 mm center to center distance. So step number 6, reinforcement for cantilever moment. So cantilever means that projection moment. So for 1 meter height above from the bottom. Okay, so we need to find out the cantilever based on 1 meter above from the bottom, based on bottom. So cantilever moment is equal to, this is our formula, h into w into 1 by 2 into 1 by 3. This is our formula, h by 2 into w by 3. You can anything you will be take. So the h is the 3.5 height of the what, then w is assume 10, then 1 by 2 1 by 3. Okay, so our answer is 5.83 kilonewton meter. Then AST, so AST is equal to cantilever moment by sigma st j into d. So we know all the values, so apply it. You got a AST is equal to 280 mm square. So provide 10 mm dia bars at 260 mm center to center distance on both sides for height of 1 meter from top. So minimum reinforcement, AST is equal to 0.3% of cross section. So 0.3 by 100 into cross section is 1000 into 240 mm is equal to 720 mm. Now next is reinforcement on each faces. So we need to find out the reinforcement for each faces, because of on walls will be divided into two faces. So AS is equal to 720 by 2, so is equal to 360 mm square. So provide 8 mm dia bars, then spacing is equal to same formula, 1000 into by d square by 4 divided by AST. So apply the d is equal to 8 mm, then AST is equal to 360 mm. So spacing is equal to 139 mm. So provide 8 mm dia bars at 130 mm center to center on both faces. You can take 140 mm also, you can take 135 or 130. Our assumption is the spacing. Then step number 7, base slab. So provide nominal thickness of 200 mm for base slab. We can provide. So ASD is equal to same formula, 0.3% of cross section. So 0.3 divided by 100 into 1000, B is equal to 1000 and D is equal to 200 mm. Just now we can assume. So AST is equal to 600 mm square. Then provide half of reinforcement near each face. So AST is equal to 600 divided by 2. So AST is equal to 300 mm square. Then spacing, so provide 10 mm dia bars on both sides. So spacing is equal to, we know that formula, 1000 into by d square by 4 divided by AST. So d is equal to 10 mm, then AST we already find it in our previous step. So AST is equal to 300 mm. So our spacing is 261 mm. So provide 10 mm dia bars at 260 mm center to center distance on both face. So see that this is our reinforcement diagram. So these are four sides of walls. So we have see that the inner face of the reinforcement and the outer face of the reinforcement. So providing 20 mm dia bars at 160 mm center to center distance and 20 mm dia bars at 80 mm center to center distance, and the corner spacings are 150 into 150 fillers. The next diagram, this is our cantilever portion. See that cantilever portion, our thickness of slab is 200 mm, then 1.5 meter above the walls, then height of the wall is the 3.5 meter. Thank you.